All right, so how do we know what the structure of a solid is? How do you know what the atomic molecular structure is? Well, there's different techniques. The most popular is X-ray crystallography, and so this allows for the determination of the structures of solid. And this is more important for material science, right? When you're thinking about just regular solids, but it's also important for like biochemistry and biological applications. So we'll say important for material science and biochemistry. This is how the structure of a lot of proteins are found. You grow a little structure or you grow a little crystal made out of many proteins, and then you analyze that crystal by shooting X-rays at it. And the gist of this is that you shoot X-rays at the crystal, and then these X-rays get scattered by the nuclei. And when these X-rays get scattered, they can interfere with one another. And so remember, we learned about waves. They can either be constructive interference or destructive. Right? If they're constructive, they sum together and they form a bigger wave. If they're destructive, right, they're out of phase, and then they cancel one another out. Right, and here's like on an image, right? The general gist is you have some kind of crystal, you shoot X-rays at it, you get a diffraction pattern, which is with those little dots, and that's where all this constructive interference is coming from. You can then develop an electron density map, and then in this case, you can build a protein model. But of course, you can do it for simple solids as well. You can check out your book for some problems. They'll include the Bragg equation, which describes the constructive or deconstructive interference with these X-rays, and do some calculations as well. I don't think it's overall that important. X-ray crystallography is still really cool and useful, but it is slowly being replaced by other techniques